Okay, so first part of this is that we have, okay, 750 meters at 30 degrees west of north. Okay, so we're going to go, okay, reference line that's north. We're going to go 30 degrees west of that, 750 meters. There's our X, there's our Y. Okay, second part of that is that it then flies 300 meters at 18 degrees south of east. All right, so we've got east here, okay, 300 meters. So it's going to go, all right, so it's going to go past, okay, it's going to go past my Y line here, right, because it's 300 meters long. Sorry, it's not going to go past my Y line here. It's going to be short of that, so I've drawn mine too big. Okay, it's going to end up short of it, so somewhere in here. Okay, how do I know that? Anybody know? Okay, the sine of 30 is 0.5. All right, that means that X, black X, is half of 750, which is more than 300. Agreed? Okay, that's how I know that. I just kind of do the trig, I estimate it, and I go, okay, now I know how to draw this line. Okay, it's 18 degrees south of east, so it's a pretty small triangle. It's like this. Okay, so maybe to about there. I wish I'd have drawn this bigger now, but okay, this is 300 meters, right? And we'll have X and Y, and that angle is 18 degrees, right? So our resultant then is the red line going from start to finish. So that red line will be our displacement. It's not what the question's asking for, but we need it to find what the question is asking for. So your diagram should look something like that. Okay, so guys, what I'm seeing just kind of walking around here is that this diagram is really like, I mean, it's busy. And unless you're, you've done a bunch of these or, you're comfortable with a lot of data on one small thing, it can be confusing. So we did talk the first day, but never really showed you on how to solve a problem like this using what's called the separate triangle method, which mathematically is exactly the same as what we're doing, but doesn't look as busy. Okay, I can use the separate triangle method on this simply by drawing those two triangles out, okay, completely separate of each other. So I still have black X, black Y. This is still a 30-degree angle. This is still 750. But now instead of drawing them tail to head, okay, I have these two triangles that are separate. Okay, this is X, this is Y, right? This one's 300 meters long, this angle's 18 degrees, okay? I can still solve for black X, black Y, blue Y, and blue X, and then find my resultant. Without seeing what my resultant looks like, I can still do all that, okay? Then I'll build a triangle with the resultants X and Y after, okay? The only downfall to this method is that you don't get to see the end result until you're almost at the end. Okay, this way you kind of get a preview, okay, of what it's going to look like. This way you don't, right? But this way is certainly less confusing to look at because there's not as much there and there's not as much stuff overlapping everything. Okay, but mathematically, the next few steps are no different. Okay, we're still going to solve for all the X's and all the Y's. All right, so let's just do that now. Okay, so I'm going to solve for black X. Okay, regardless of which one I look at, black X is the opposite side to the 30-degree angle. So it's sine of 30, okay, degrees times 750. All right, so we're looking at 375 meters, and that is west. Okay, and for black Y, it's the adjacent side, so the cos of 30 times 750. Okay, 649.519. And that's meters, and it's north. Then I'm going to do the same thing for the blue triangle. Okay, so on the blue triangle, okay, X is the adjacent side. So that'll be the cos of 18 degrees times 300 meters. And then Y is the opposite, so it'll be the sine of 18 times 300 meters. Okay, so 285.317 meters, and that one is east. Okay, and then for y, sine of 18 times 300, all right, it's 92.705 meters south. All right, so now I have, okay, all of the x's and all the y's. Now I'm going to continue on with separate triangle method rather than this method, just so that you see what one of these looks like. Okay, so I'm going to continue on with this by finding what my resultants x and y are, right? But without looking at them. Just grab. Okay, so I'm going to use still red just so it kind of matches up, but I'm going to find red x and red y. Okay, now red x is the sum of blue x and black x. Okay, but the issue here is blue x and black x are opposite. One is west and one is east. So I'm going to take the larger number, which is west, okay, the 375, and I'm going to subtract the east, which was 285.317, and get my resultants x. Okay, so 375 minus 285.3169549. Okay, so my resultant x is 89.683 meters. And that is west. All right, and then my y component, okay, the bigger one is north, so I'm going to take the north and subtract the south. So that will mean I'm taking the 649.519 and subtracting the 92.705. Okay, so I've got a resultant y of 556.814 meters, and that's north. Okay, so now, using the separate triangle method, what I do is I build a triangle with these two dimensions, and that'll be my resultant. Okay, so my x component is 89.683 meters west. And my y component is 556.814 meters north. Okay, and then my resultant goes here. All right, that resultant is the total displacement. This is its vector. Okay, that triangle and this triangle, I mean, they're not quite exactly, but they mean they're going to have the same dimensions, right? So I still ended up with the same triangle, even though I didn't see it from the beginning. I didn't have to look at it from the beginning either, is the other side of that. All right, if that whole diagram was being too busy for you. All right, then again, if the math is all still identical, now I use Pythagorean Theorem to get D. Okay, so I can take my 89.683 squared and add it to 556.814 squared, right, and get my answer. I'm going to shortcut here, guys, just to save time. I'm cheating. I shouldn't do that, but I am. Okay, so I'm going to get 564 meters. Okay, and then I'll find theta, same way I always have, 10 to the minus 1 of opposite. So for me, that's the 89.683 over 556.814. Right, that'll give me my angle. All right, so I'm getting 9.149 degree. Yeah, so I'm only going to have two significant figures here, so it's going to stay at 9.1. 9.1 degrees, and that is west of north. Okay? So actually, I think my first triangle was more accurate. The one I drew in here was probably more accurate in terms of size than that one was. But in the end, I get the same answer, regardless of whether I separate the triangles or whether I draw them all together like I did here on the right. Okay? The math is exactly the same. But if one is more visually appealing to you, then do it that way. Okay? Whichever way is going to work. The separate triangle method is nice when you have a lot of backtracking. All right? It does then kind of lead to you getting confused about your lines a lot less. Okay. All right, question. Now, am I done yet? No. What did this question ask for? Velocity. So I just calculated displacement. Now I need to calculate velocity. Well, the whole trip took 380 seconds. Okay. So now I need to calculate V. Well, I have D and I have T. So the velocity is simply going to be my 564 with all the decimal places. I would keep all of those. Okay. Divided by the 380. Okay. So 563.9900889 divided by 380 seconds. Okay, so we're looking at 1.5 meters per second at 9.1 degrees west of north. Okay, or the other angle if you drew it the other way. Okay, so 81 degrees north of west if you drew it the other way. All right, so whichever way works for you guys, I'm fine with, because like I said, mathematically there is no difference between the two methods. Visually there is. All right. Okay, I want you guys to keep working on the vector worksheet from the other day, because judging by our quizzes yesterday, we still need some practice on that. All right, let's have a look at number 12 here. Okay, so this is a boat question where we definitely want to draw the river. Okay, we want to visualize a question. Okay, as much as we can, like depending on your learning style, you either want to visualize it or read it out loud to yourself, depending on how you best process things. For me, I'm totally visual, so I have to draw pictures, okay, or storyboard things or whatever, even though I can't draw, which does make that difficult. But okay, so here's what I've got. I've got the river, and I know that the river is 125 meters wide. Okay, that's a displacement. Okay, not a velocity. So I'm not putting it in my triangle with the velocities I'm about to draw, because they're not the same thing. Okay, that's like putting apples in a box of oranges. They don't go together. Okay, so the next thing I have is my rowing velocity, 4.0 meters per second, and my river current, 2.1 meters per second. All right, so that's what I have from the question. That's what the question gave me. The first thing the question wants is, what is the velocity of the boat with respect to the shore? The way I've drawn this is not going to give me the direction relative to the shore. I will have to make one little correction when I'm done. Okay, it'll give me the right magnitude, but it's not going to give me the direction relative to the shore, because I'm drawing the triangle like this, which means I'm finding this angle. Relative to the shore is that angle, because it's measured from the shore. So this is actually a question where there are not two correct vectors. There's only one. Okay, it would be like another question asking you, what is the direction of this relative to due east? So if you gave me east of north, you'd be wrong. That's relative to due north. Okay, it was once relative to the shore. All right, not hard. I'm just going to go 90 minus whatever I get for theta, and I'll have my answer. Okay, it's not a tough calculation. So first thing I need to do is find my resultant velocity using Pythagorean theorem. Okay, so I'm going to have 4 squared plus 2.1 squared, okay, and that'll come out to 4.5 meters per second, and then I'm going to find theta, but here's what I'm going to do. In order to get the right angle, I'm just going to flip my triangle. I'm going to go 4.0 and 2.1. Now I'm finding the angle that's inside or the angle that they want. Okay? Or I could go 90 minus, whichever, it doesn't matter. Okay, so I'm going to go theta equals tan to the minus 1 of 4 over 2.1, and that will give me my 28 degrees. They say east of north in here, but that's not right, because it's not relative to the with respect to the shore. Okay, with respect to the shore is going to be the other angle. Okay, so I'm not going to write 28 in there because that's not the right answer. Okay, so I'm going to have 10 to the, whoop, not 10, 10 to the minus 1 of 4 divided by 2.1. So relative to the shore is, no, I put 21. No wonder it didn't work. Okay, is going to be 62.3. I only have two significant figures, so 62 degrees from shore. Okay, or I could go north of east, okay, because they also gave north and east in the question, so either way. All right, so that's for part A. I will never use those numbers again, okay? Those numbers point this direction. Everything else the question asks is about straight across the river or downstream. This is neither of those. It's the combination of the two. So once I've solved for that, I'm done. I never use that number again. Okay, now I need to calculate how long it takes the boat to reach the opposite shore. Okay, well, that means I have to use how far it is across the river and the velocity that points that way. I can't use this velocity, the red line, because it doesn't point straight across the river. Right? It would be like asking somebody how long it'll take you to go straight north 100 kilometers by going north or by going east. It just doesn't make sense. You can't, they're not the same thing. They're not pointing the same direction. All right, so I'm going to find out time here by doing simply a V equals D over T calculation. So T equals D over V. It's 125 meters across. I'm moving at 4 meters per second. Okay, and so I should get 31 seconds to get across the river. Okay. What's going on in the river is I am going across and downstream at the same time. That's why if I was, I had a drone kind of watching this, I would see someone doing the red line. Okay, they would be moving like this. Okay, but from a vector perspective, this happens, then this happens, even though they're happening at the same time. So the whole time I'm going across, all 31 seconds, I am also moving downstream at 2.1 meters per second. So this time can also be used here because time isn't vector. Time is scalar. So I can apply it to both an across and downstream number. Okay? Whereas I couldn't apply this 125 to this because they're both vector and they don't have the same vector. Okay? Everyone follow there? So I can put a scalar quantity with both of them because they share it. As long as I'm in the water, I'm doing both of these things. So I can figure out how far downstream by doing another V equals D over T calculation, okay, in order to get distance. I'm going to use the 31 seconds times the 2.1 meters per second, how fast I'm going downstream, and it's going to be 66 meters downstream. Okay. So the vector part of a boat question is really easy. Okay, and then there's a couple of V equals D over T calculations after that, right? It's just perpendicular vectors to find the resultant. Okay, that's no problem. It's Pythagoras and one trig calculation. What's tricky about these is realizing what numbers can be used together. You can use numbers together that point the same way, and that's it. All right. Now, the other kind of boat question we went over is the ones where it's looking for the heading. Okay, and we've done a couple of those already, but this wasn't one of those. All right, questions on that one? All right, keep going. I might make up a boat question about headings for Monday morning, okay, so that you can see another one of those. Whoops.